Okay, this is just a quick video on special triangles that we learned in class. Okay, so up until now we've been using a calculator to evaluate the sine, cosine, and tangent of any angle. So if we just wanted to figure out, hey, what's the sine of 60 degrees? So maybe we just wanted to figure out what that equals. We just plugged it into our calculator, hit sine 60 on our calculator, and our calculator just told us, hey, it's 0.8660254, etc. But now, turns out, we figured out these two special triangles in class so that we can get more exact values for our trig ratios, and we don't have to use a calculator to evaluate them. So our two special triangles that we did in class today, one, we started with an equilateral triangle, and we split it in half to form a 90-degree triangle. And it produced angles of 30 degrees, 60 degrees, and then the 90 degree. And so our equilateral triangle started out with all sides having a length of 2. So then the bottom had a length of 1 since our triangle got kind of split in half. And then we figured out our third side using the Pythagorean theorem. 2 squared minus 1 squared was 3, and then we took the square root. So we got the square root of 3. So that was one of our special triangles, the 30, 60, 90 degree triangle. And then our other one was our isosceles triangle. And it started with two 45-degree angles and a 90-degree angle, and our isosceles triangle has two sides that are the same length, so we did 1, and then if you figure out the hypotenuse, 1 squared plus 1 squared is 2, and then you have to take the square root, so the hypotenuse would be root 2. So these are our two special triangles that we need to know, and then we can calculate all of our 3 trig ratios of any angle without using a calculator. So for example, if I wanted to say find what's the sine of 60 degrees now without using my calculator, I can look at my special triangle here, the 60-degree angle, and I can just say, okay, what's my opposite and my hypotenuse? Because I know sine is opposite over hypotenuse. So opposite is root 3 and hypotenuse is 2. So sine 60 equals root 3 over 2. I could also find cos of 60. So if I wanted to find the cosine of 60 degrees, I know cos is adjacent over hypotenuse, and adjacent is 1, and hypotenuse is 2, so cos 60 is just a half. And then if I wanted to find tan of 60, tan is opposite over adjacent, so opposite's root 3, and adjacent is 1, so root 3 over 1, or just root 3. I could also use these triangles to find sine, cos, and tan of 30, and sine, cos, and tan of 45. So we'll just do a couple more random examples. So say we wanted to find the sine of 45 degrees. So if we picked any 45-degree angle, opposite over hypotenuse would be 1 over root 2. And I'm going to teach this concept tomorrow, but we actually don't want to have a radical sign in our denominator. We don't want to have a rational number down there. So we have to do something kind of crazy. We have to do something called rationalizing the denominator. So we actually have to multiply the top and the bottom of the fraction by root 2. Because what that does is it gets rid of the root 2 in the denominator, because root 2 times root 2 ends up being square root of 4, and the square root of 4 is just 2. And then the top becomes 1 times root 2, so it's just root 2. So that's kind of crazy. So tomorrow I'm going to talk about that. But sine 45 equals 1 over root 2, and I just switched that to root 2 over 2 just so I didn't have a rational number in the denominator. Okay, so anyways, back to special triangles. So you can use them to evaluate the 3 trig ratios without a calculator.